across a video of a spacecraft making it to the sun. Now, included in this video is audio. Now I have two questions. In order for me to believe this video,
I got two answers for you. Matter of fact, if you buy right now, I throw in a third bonus answer. No extra charge, just purely off the strength. I'm just that type of guy.
we've been told that space is a void of no air, no sound. How are we hearing solar wind?
Good question. Remember, sound is just a wave of energy that's propagating through a medium. You need a medium. In space, where there is a low density of molecules, it's not really possible for sound to travel. There are no molecules that can propagate that sound. When NASA says they heard the sound of the sun using the Parker Solar Probe, they're not saying that they stuck a microphone out in space. Think of data visualization. Everybody has seen graphs, plots, pie charts. This is not what data looks like. This is one way to present data. You can have an auditory presentation. This is called data sonification, converting those measurements into a sound that we can hear. It's just another way to understand data. Furthermore, while most of space is empty, there is indeed a solar wind. There is actual mass, large particles constantly coming off of the sun. The closer you get to it, the higher the density of those particles. Those measurements can be converted into sound.
If the sun is indeed 93 million miles away from planet Earth, when did you launch the spacecraft?
This one's pretty easy. It was launched in 2018, several years ago. You can look this up. It was all videotaped. I promised you a bonus answer, and I intend to deliver. The real question you should be asking is, how is a man-made spacecraft able to withstand the temperatures of the sun? The sun is blocked out here, so you can see the solar atmosphere. This is called the corona. The corona out here can be heated to millions of Kelvin. This is footage from the Parker Solar Probe. This is what it's seeing. All these white dots, of course, are particles from solar wind. It is in the corona in this video. There's the Milky Way. That's the band, the central disk of our spiral galaxy. There is a carbon composite heat shield that keeps the instruments essentially at room temperature, even though the coronal environment that the probe is in for at least part of the time is millions of Kelvin. Quite an engineering feat by NASA.